Here we go. Um, this is where things get a little weird, right? So this says simplify the following complex rational expression. I like to call these types of problems nested, okay? And I don't even know if that's a technical term or a mathematical term, but I think about Russian nesting dolls. If you guys have any concept for those, where there's, you've got it's shaped kind of like this, not at all like that. My drawing skills are awful. And then like the top comes out, and then on the inside, it's kind of like the same thing. You get what I'm talking about. So I call them nested because you've got fractions within fractions, right? So that's why I consider it a nested rational expression. And there's a couple of different ways we can attack a problem like this. In terms of simplifying it, what that means is they don't want this fraction inside of this other fraction, okay? And there's two methods that we can go about this. One method is and I'll just leave this up here, okay? Because this is a fraction, if you multiply the numerator and denominator by the same thing, you're multiplying by 1, right? So think about if I had a fraction that was like 2/3. If I multiplied the top by 4 and the bottom by 4, I'd be multiplying by a value of 1, right? Why am I choosing 4? Because I can choose anything as long as it's the same on the top and the bottom, and I'll get an equivalent fraction to that, right? It's making it bigger, but it's equivalent. And so one method for doing this is to multiply the numerator and denominator by the denominator of the nested fraction, okay? And there could be more than one. We'll look at a different example here in a second. So what I mean by that is when you look in the numerator, there is another fraction. The denominator of that fraction is 9. So if I multiply the top by 9 and I multiply the bottom by 9, so I'm only doing all of this multiplying by 9, and I'm multiplying all of this by 9. What's going to happen when I multiply 9 by this first part of the binomial? Well, 9 is really, and this is, fraction math, hopefully we're comfortable with this, but 9 is really 9 over 1, right? Like as a number, as a fraction. So when I multiply an integer by a fraction, I can just put it over 1. So this is 9 over 1 times x over 9, right? And we can go slow here. This is 9x over 9. Then when I do 9 times 1, I end up with just minus 9. And on the bottom, when I do 9 times x, I'm going to get 9x. And when I do 9 times negative 9, I get negative 81. Right? So I have to distribute this number. The only reason I wrote this 1 here was because some people are uncomfortable multiplying integers by fractions. So if you're uncomfortable multiplying an integer by a fraction, put a 1 underneath it. Okay? Now it's 9 over 1. And when we multiply fractions, we multiply straight across. 9 times x and 1 times 9. So this is my new expression. Okay, and when we get this, what really happens is these 9s, we talked about this before, the product in the numerator, this 9 cancels with this 9. So we end up with x minus 9 on the top, and on the bottom, we have 9x minus 81. And you would think that we'd be done at this point, but that's not exactly how this works, right? Math doesn't always abide by what we want it to do. So when you look at this denominator, okay, we can factor out a greatest common factor here. If we factor out what's common to 9 and 81, 9, right? And if we factor out that 9, we get x minus 9. Now, in hindsight, should I have even multiplied this 9 times this binomial? Because I ended up with that anyway, right? But I didn't know that at the time, so I followed through with all of those operations. I get to here. Now, when you look at this, okay, what you see in the top is x minus 9. What you see on the bottom, there is another x minus 9, and that x minus 9 is being multiplied times this. So as we've said already here today and already in a previous video, because the x minus 9 is a factor of the denominator, if I see that factor also in the numerator, I can cancel them. So because this x minus 9 is being multiplied by this 9, I can cancel it with this. And I'm going to expand on this a little bit. So these are going to cancel, and I'm going to be left with a 1 on the top and a 9 on the bottom. Okay? Now, they may, as a part of this, as in the end, they may say, are there any values to exclude? Keep in mind, okay, x can't equal 9 because if x equals 9, I'm not allowed to let the denominator equal 0, right? This may come up, I'm just giving you a heads up right now. Anytime we deal with a rational expression, we've got to be conscious of denominators not being equal to 0. Okay, so it may ask you for this exclusion at the end. Just be careful with that when you're working in Math Excel. Okay, I'm going to come back here for a second and talk about what I was mentioning here before. If I had this rational expression, okay, and you look at that and you're saying, how, this looks the same as that, but it's not, because the x minus 9, this x is attached to this 9. So it is not a factor. Same thing here. This minus 9 is not a factor of the denominator. This minus 9 is a part of this product. So I can't cancel this with this because this is not a factor. Factors are things that are multiplied together, right? There's no parentheses here. There's no indication of multiplication up here. Same thing with this negative 9. So these don't get to cancel. Yes, they line up vertically. That's great. Those don't cancel. The only things I'm allowed to cancel are pieces that are being multiplied together, and only if they're a part of the denominator and the numerator. It gets really hairy with some of this stuff, and we'll try to deal with it on a case-by-case basis. But I just wanted to make sure you guys understood what I'm talking about when I say factors can be canceled, okay? The second method for doing this we'll talk about in the next video, all right?